Hi, once again I welcome you all to the SPP Math Lecture. Today I am here with you Assertion Reasoning Type MCQ. You know that this year CBSE is going to us Assertion Reasoning Type MCQ. According to the change of pattern, I will teach you how to tackle these questions. Let me briefly tell you about this. We have two statements. First statement is assertion, second statement is reason. Actually, assertion is the simple statement. Second statement is the reason behind the statements. There are four options. We have the first option, both assertion A and reason R are true, and reason R is the correct explanation of A. Second option, both assertion A and reason R are true, but reason R is not the correct explanation of A. We have our third option, assertion A is true, but reason R is false. Assertion A is false, but reason R is true. I am sure you might have some confusion about option A. Let me tell you how to solve this problem. What you do is you try to understand the first statement. Then if you can connect the second statement, with because, that means if the second statement is the correct explanation of the first statement, therefore you can go for the first option. If you can connect these two statements with because, second statements, if you are able to connect with because, definitely the answer will be option A. If you cannot connect with because means if this is the not the correct explanation of the second statement, you will go for the second option. In sometimes both the statements are not match at all, they are not match at all. That time we have to go for either of these, option C or D. Now let us come to the question. We have first statement assertion 5 minus root 3 is 1, 0 of the quadratic polynomial. Then the other 0 will be 5 root 3. 1 0 is 5 minus root 3. Then other 0 of that polynomial will be 5 plus root 3. Absolutely correct answer. As irrational expressions are always occur in pairs, we know that 5 minus root 3 is the 1 0. Definitely 5 plus root 3 will be the other zeros. If 3 plus root 5 is the 1 0, other 0 will be 3 minus root 5. Therefore, assertion first statement is true. Whether the second statement is the correct explanation or correct reason of the first statement, of course that is not so true. Irrational zeros are always occurring pairs. Therefore, this option is true. Second, this statement is true. Reason also true. Therefore, our correct answer is option A. Both assertion A and reason are true, and R is the correct explanation of A. Okay, moving to the second question. Assertion: if 1 0 of the polynomial k square plus 4 into x square plus 13x plus 4k is reciprocal of the other, then the value of k is equal to 2. We know that zeros are alpha and beta, but according to the question, 1 0 is reciprocal of the other. Therefore, we will be taking the zeros. How will we be taking the zeros? We have to take alpha and 1 by alpha, because 1 is the reciprocal of the other. We have the zeros alpha and 1 by alpha, because 1 is the reciprocal of the other. We know that sum of the zeros negative b by a, product of the zeros c by a. Alpha plus beta negative b by a, alpha beta equal to c by a. Let us take this formula. Alpha beta is equal to c by a. Then definitely this alpha will be cancelled. We can find the value of k easily. We know that alpha beta is equal to c. Therefore, alpha into 1 by alpha is equal to c by a. We have a c 4k by, we have a is equal to k square plus 4. This is cancelled. While cross multiply, k square plus 4 is equal to 4k. K square minus 4k plus 4 is equal to 0. Therefore, a square minus 2ab plus b square, we can factorize by using a square minus 2ab plus b square. Therefore, this is k minus 2 whole square is equal to 0. Therefore, k minus 2 is equal to 0. Therefore, the value of k is equal to 2. Therefore, our assertion 1, first statement is absolutely correct answer. Answer is 2. Now we will go for the second statement. Second statement, second statement is actually a reason behind the statement. We have to check whether the second statement is a correct explanation of the first statement. I think if x minus alpha is a factor of p of x, then p of alpha is equal to 0. X minus alpha is a factor means what is a 0? X minus alpha is a factor means we know that alpha is the 0 of the polynomial. I think this reason is not the correct explanation for the first statement. This is not the correct explanation. Therefore, of course, this statement is true, this statement also true. Both the statement true. First statement is true. So, like that, second statement also true, because if x minus 5 is a factor, we know that 5 is a 0. X minus 6 is a factor of the given polynomial. 6 is a 0. Like that, here x minus alpha is a factor. We have p of alpha 0, that is alpha is 0. But here no argument about the statement. Both the statements are true, but this is not the correct explanation of statement 1, assertion. Therefore, our correct answer is option B. Okay, next one. We have assertion p of x equal to 14x2 minus 2x square plus 8x raised to 4 plus 7x minus 8 is a polynomial of degree 3. Is this statement true? I think this statement is false. We know the degree of the polynomial is the highest power of the variable. We have the highest power of the variable is 4. Therefore, degree of this polynomial is 4. Therefore, the first statement, assertion, is false. Now, let us see the second statement. The highest power of x in the polynomial p of x is the degree of the polynomial. That is absolutely correct statement. This is the correct statement. This statement is false. This statement is true. If the first statement is false, we are sure that A or B or C is not our answer. Already first statement is false. Definitely the correct answer is option D. Moving to the next question. Assertion x cube plus x has only one zero. Reason, a polynomial of nth degree must have n real zeros. Okay, let us see how many zeros will this polynomial have. We have x cube plus x. We know how to factorize this. X cube plus x. We should take the common factor and we can factorize. X is the common. X square plus 1 is equal to 0. Therefore, x equal to 0 or x square plus 1 is equal to 0. X equal to 0 or x square is equal to negative 1, then x is equal to root negative 1. Therefore, this is not a real zeros. This is not real root. This is imaginary root. Therefore, we are getting only one zero. How many zeros does this polynomial have? We have only one zero. Therefore, this statement is true. Now, according to the second statement, reason, actually this second statement is false. The second statement says like that, a polynomial of nth degree must have n zeros. If a polynomial of fourth degree must have 4 zeros, that is false. Actually, this is a polynomial of third degree. Do you get the 3 zeros? We get only 1 zero. This is not a real zero. We can count only real zeros. A polynomial of nth degree must have n real zeros. That is false statement. Therefore, assertion A is true, reason is false. Then we have to go for the option C. Option C is the right answer. Assertion A is true, but reason R is false. Okay, moving to the next question. If both zeros of the quadratic polynomial x square minus 2kx plus 2 are equal in magnitude but opposite in sign, then the value of k is equal to 1 by 2. Here a second reason, second statement, sum of zeros of a quadratic polynomial is negative b by a. First let us see the given statement. First statement is true or not. Let's see. Now we have, according to the question, we have the zeros are reciprocal. Zeros are equal in magnitude and opposite in sign. Zeros are equal in magnitude but opposite sign. Last time we have done reciprocals, zeros are reciprocal to each other. That time we will be taking the zero alpha and 1 by alpha. Zeros are reciprocal to each other, alpha and 1 by alpha. Therefore product of alpha and 1 by alpha will be 1. But here according to the question, zeros are equal in magnitude but opposite in sign. Therefore sum of the zeros will be 0. Let zeros are alpha and negative alpha. Therefore alpha plus beta, we know that alpha plus beta is equal to negative b by a. We have alpha and negative alpha. We have our a is 1, coefficient of x power 1, coefficient of x we have negative 2k, coefficient of last constant term we have 2. Alpha plus negative alpha, zeros are equal in magnitude but opposite in sign. Therefore alpha plus negative alpha is equal to negative of negative 2k divided by a we have 1. Therefore 0 is equal to 2k by 1. Therefore our k is equal to 0 into 1 by 2. K value is 0. The value of k is equal to 0. Therefore our assertion is false. Assertion is false. Now let us see. Sum of the zeros of a quadratic polynomial is negative b by a. That is of course correct. This statement is true. This statement is false. Therefore our correct answer is option D. Assertion A is false. Assertion reason is true. But reason is true.